Hi students, I am Mathan, Assistant Professor, Mechanical Department in PSN College of Engineering. So now we discuss in finite element analysis. The main objective of this subject to introduce the concept of mathematical problem of real life engineering problems. Okay. First, in this method, that is mean for the first of all, it is a definition of finite element. Okay. First, the finite element analysis is a numerical method for solving engineering applications. So, in this method, we can in which the analysis the real life problems. First, we take one body. This body is divided into small number of dimensions. First, we divide small dimensions. This small dimensions element is called as element. So these are the elements are connected in points. This point is called as nodal. So this is a element and this is a nodal. Next one is main concept of finite element analysis. First, we draw the x-axis and the y-axis. X-axis mentioned for number of element. Y-axis mention of accuracy. Okay. First, the number of element. So this body is number of element is increase. The accuracy also increase. So whenever the number of element increase, the accuracy will be constant. It is a main concept of finite element analysis. Next one is there are two type of problem we can solve. First one is structural problems. Structural problems. The structural problem means is a displacement at each nodal point. So this displacement are like stress, strain can be calculated. So second one is non-structural problem. Non-structural problems. So this problem, each element can be calculated temperature or heat flux. So like so you find out the temperature and heat flux for non-structural problem on each element. Okay. Then next one is there are first one-dimensional element, two-dimensional element, then three-dimensional element. Okay. First one-dimensional elements example linear bar element, then beam element. Example, it is one element and two node 1 then node 2. It is called one dimensionals, and then each node have moving on any one directions, that is when x or y or z. Then two-dimensional element. Two-dimensional elements example triangle or rectangular elements. Okay. So the triangle elements one elements and 3 nodes. Nodes 1, 2, 3. So one element is have 3 nodes. It is a this each node have moving on x, y or y, z or z, x direction. This is a plane. So each node have moving on any two planes, xy or yz or zx. It is a two-dimensional element. Then three-dimensional element. The example means tetrahedral or hexahedral elements. So hexahedral elements means hexagonal element is a one element and 8 nodes. 8 nodes is there. 8 nodes. It is called as a three-dimensional element, and each node is moving on x, y, z plane. X, y, z plane. So it is a one-dimensional element, two-dimensional element. The last is a three dimensions elements. Okay, students. Then now we can solve one problems. For example, three-dimensional elements problem. We can find out the displacement. We can find out the displacement. So I can solve the one example. So we consider one bar. We consider one bar. The first end and the last end is a fixed. It is a fixed. So there are this bar element. We can divide in two elements, element 1 and element 2. Then each element will have node u1, then u2, then u3. Okay. So there are two elements, there are 3 nodes there. So next, one axial load is acting on point B. This name is 200 kilonewton. 200 kilonewtons. Okay. So we are find out the find means the displacement at a point B. That is mean u2. We find out the u2. So there are different type of values there. First element 1 and element 2. So the element 1 and element 2's data is given. So first data is A1 means 2400 mm square, and element 2 area means 600 mm square, and the Young's modulus of element 1 means 70 into 10 power 3 Newton per mm square, and element 2, the Young's modulus 2 is equal 200 in 10 power 3 Newton per mm square. Then the length of this element 1 means 300 mm, and element 2 length is 400 mm. So L1 is equal 300 mm, then L2 is equal 400 mm. Last one is the force, axial load, that is mean axial load acting at a point B, that is mean F2 is equal 200 kilonewton. We convert the 200 in 10 power 3 Newton. is a given of this problem. Okay, next we find out this displacement of u2. Next one thing is u1. Here the u1 value is 0 because there is no displacement at node 1, and u3 is 0 because the last and the nodal 3 is fixed. There is no more movement, there is no more displacement is also there. So this is a u1 and u3 is 0, and u2 is unknown values because it's not fixed. It have some values there. Okay, so you find out the u1 0, u3 0, and u2 is unknown values. So next, can I solve that u2? Okay, the general FEA formula. FEA general formula means F vectors is equal to K matrix and U vectors. It is a one-dimensional problem. Already we told it is a one-dimensional. So one-dimensional problem. Okay, it's a one-dimensional. So first we can solve. We take element 1. The element 1 means it is a element 1. The nodal value u1, u2. So the length means the length is 300 mm. 300 mm. So first f1 and f2 vectors equal stiffness formula means AE divided by L, because element 1 means A1, E1, L1, and put the 1 minus 1 minus 1 1. So there is a displacement 1 and a displacement 2. So okay, we are applied for the A1 values. A1 values the 2400 in 10 power into, then E1 70 into 10 power 3 divided by L1 means 300. So 1 minus 1 minus 1 1. So u1 and u2. So we are simplify that. So it means 560 into 10 power 3. So 1 minus 1 minus 1 1 is equal u1 u2. So next 560 we multiply the matrix. So 10 power 3 is we take the outside, remain value 560 minus 560, next minus 560, next plus 560 is equal to u1 and u2. It is a equation 1. It is a equation 1. Next we put the node value. Node value put the rough copy. The roughs 1 2 1 2. This is to mention that. Next we find out the element 2. Next we find out the element 2. So element 2. Element 2. So we draw the element 2. The node number is u2, u3. The length is 400 mm. Okay. So next general formula means f2, f3 is equal a2, e2 divided by l2. So 1 minus 1 minus 1 1 and u2, u3. Because it's a element 2 values. Okay, already you know A2 value, you know, is a A2 600 into E2 200 in 10 power 3 divided by L2 is 400. So let's substitute all the values. U2, U3. Okay, students. Next we are simplify. So 300 into 10 power 3. 1 minus 1 minus 1 1. So u2 u3. Okay. Next 300 values multiple matrix ones. So 10 power 3 we take outside 300, so multiple matrix 1. u2 u3. It is a value of f2 f3. It is a equation. Next you put the nodal values. Nodal values 2 and 3. So 2 3 2 3. It is a equation 1. Next we are assembling the element 1 and element 2. Next part is assembly section. Next part is assembly section. Assembly. So there are two elements. Okay, elements 1, then elements, that is element 1 and element 2. Element 1 and element 2. Okay. So here f1, f2, then f3. Then the 10 power 3 is common values. So you put the nodal value 1, 2, 3, 1, 2, 3. Because you put the nodal points. Next u2, u1, u2, then u3. Okay. Okay, students. Next we assembly that here is a first row, first column. First row, first column values. Okay, first row here, first row, first column. First row, first column value is 560. 560. So 560. Then second column, first row, second column values. First row, second column values minus 560. Next, first column, that first row, that column is not there. So you will put the 0. So same as second row, first column. Second row, first column. Second row, first column is minus 560. So 5 minus 560. So next is second row, second column. Second row, second column values 560. 560. Then equation 2, you see that equation 2 same first second row, I mean 2 cos 2, second row, second column. So 300 values is there. So already equation 1 means second row, second column is there. The equation 2, second row column is there. So you put the 300 values added. So same as 2, 3 values. Equation, you see the equation 2, second row, third column value minus 300. And that row, first column is not there, so 0. Second row, second column is plus 30. That is mean plus minus 30. Minus 30. And that row, that column is plus 30. Plus second row, that row, that columns is says 300. So this. So it's a assembly. Okay. Let put the all the values. So already we discussed u1 0, u3 is 0. So this two values substitute this main equations. Then f2 values put the equation here. You put this equation. So 10 power 3. F1 value you don't know. F2 value 200 in 10 power 3. And F3 value is unknown values. Then 560 minus 560 0 minus 560. Next 860 is adding. Okay, so we get 2 is adding minus 300. 0 minus 300 plus 300. So u1 value is 0, then u2 is unknown value, u3 is 0. So here u1 0. So first row, first column eliminate. Then u3 is 0. So that row, that columns eliminate. So remain values 200, 860 and u2. Then 10 power 3. This value is there. So you take this value. You take these values. So 200, 210 power 3 is equal to 860 into 10 power 3 u2. So you find out the u2 is equal to 200 in 10 power 3 divided by 860 in 10 power 3. So this value is u2 is equal to 0.23. So finally we got the displacement at point B is can find out. So u2's value is 0.3. So finally the result is u1 0, u2 0.23 and u3 is 0. These are the displacement at each nodal point is the answer. Thank you, students. In the next section, we will solve the two-dimensional problem. Thank you.